Hello, we have chosen multi-ant colony optimization for vehicle routing problem with time windows for the project of programming for analytics course. This project is done with reference to the research paper called Time Dependent Vehicle Routing Problem with a multi-ant colony system that is published in European Journal of Operational Research by Alberto V. Donati. With the rapid growth in industry size and the necessities of the people, supply chain became the backbone of many organizations. The aim of the supply chain is to route the products from depot to all its customers within the shortest time and with the shortest possible trips. This vehicle routing problem is an integer programming problem which makes it a NP hard to solve to optimality, but this can be solved using knapsack within the polynomial time. Heuristics play a major role in achieving better solution than the IP model within the shortest duration. And colony optimization is considered the best to solve vehicle routing problem with time windows. When it is combined with local search methods, and colony optimization is one of the best method to solve the vehicle route problem. And colony optimization mimics the nature of ant. It travels in the search of food. When an ant finds its food, it deposits a small amount of a chemical substance called as pheromone on its way back. The quantity of pheromone on any path will guide other ants to the path that they can find the food. In this project, we have considered to test with the solvents problem data, but the problem with this data is this data has a locations of wide range of customers across the world. We use MapQuest API to collect the distances from one customer to other customers, but the limitation from MapQuest API is that we can collect the distance for only 25 customers at a time, and the customers should be within a limit of maximum of 12,000 miles. So to avoid this problem, we coded a program that will call the MapQuest API repetitively using the one-to-many parameter and will construct the distance data frame. Multi-ant colony consists of a group of ants that explores the feasible region to find a better solution. The initial solution is generated from the nearest neighbor algorithm, which is coded by us for a vehicle routing problem with time windows. The ant is constructed starting with a depot and choosing the customers until the vehicle has some quantity left in it to serve the customer, or if it has to reach the depot as the depot will be get closed. Each route is made from a depot to a set of customers and back to the depot, and which makes a trip. A set of feasible trips will be a tour that covers all the customers. The ant makes the choice of customer to move in the next step based on the probability, which is a product of pheromone level and a local heuristic value. The higher the pheromone level on the customer path, the more likely the ant chooses that path to serve that customer. Local heuristic function prioritizes the customers based on distance, demand, and waiting time. Only a few customers who satisfy three conditions will be feasible for the ant to take the next step. The three conditions are: vehicle can reach the customer by the customer end time, and the quantity left in the vehicle should be sufficient to serve that customer, and the vehicle should be able to reach the depot by its closing. Once a feasible customer set is generated, to avoid the local optima, a random number is generated and is compared with the cutoff parameter. If the random number generated is greater than the cutoff parameter, the customer is chosen randomly, and this process is called exploring of the trip. If the number is less than the cutoff parameter, then the customer with the maximum probability is chosen, and this process is called exploiting. In this process, we use multi-ant colony system. Each colony has different objectives to solve with. One is to minimize the travel time, and the other is to minimize the number of trips. Each of this ant colony system has a group of ants that explores the feasible region. Also, As the local search procedures expedite the process of exploration of feasible region and guide towards the local optimal solution, various local search procedures were suggested by the author in this paper. Because of the lack of pseudocode in this paper, we had to refer with some other papers to write a program for this local search procedures. The local search procedures we considered are exchanging of the branch, and this is made by selecting two nodes of one trip and looking for the possibility of exchanging with a branch of another trip. All the feasible changes will be generated and compared for the minimum travel time. The next method of local procedure we consider is the branch relocation. In the branch relocation, we'll choose a set of customers in one trip and relocate it to at different positions of the other trips. This has a highest number of possibilities. Due to the repetitive process of exploring all the feasible possibilities for this method, the slack time and slack quantities were of great help in choosing the feasible combination. As the ant colony system for minimizing the number of trips may lead to a infeasible solution, a local search procedure called as post insertion is considered to make the undesired infeasible solution to a feasible solution. This process will check all the possibilities of inserting the unscheduled customers into any of the trips as to serve every customer and make the tour feasible. The multi-ant colony system is coded in Python and along with the local search procedures to solve the vehicle routing problem with time windows. While solving the vehicle routing problem with time windows using the multi-ant colony system, we are generating a live progress of the solution using matplotlib library. This consists of three plots. The left plot showing the convergence of MACS multi-ant colony system algorithm, while the plots on right shows the progress of individual ant colony systems. The bottom right plot will be updated repetitively as the ant procedure is invoked. In this process, we have used 10 ants to explore the feasible region every time. So we can see that there are set of 10 ants which forms a ant colony system. After a sufficient time, it can be seen that most of the ants that belong to this colony take the same path that leads to a good solution. This is due to the amount of pheromone available on that arc. We observe that the ant constructive parameters that include the cutoff parameter and the evaporation parameter plays a vital role in the convergence of the solution. We tested with different combination of parameters and found that 0.9 as a cutoff parameter and 0.1 as a evaporation parameter, as suggested in the literature, serves the purpose well. Due to the lack of real-time speed data for the randomly generated locations, we were unable to implement the speed changes in the problem. We wish to implement the same in the near future. Thank you.